This is John Black, Super Chemist. I can't believe it's part 5. I was thinking, once you get to this, remember the free radical NO came and plopped a hydrogen off and made this a free radical. Maybe this free radical attacks a water or an OH molecule in some way and attaches an OH on here. And then another, and that just repeats itself. The NO comes in, plops off a hydrogen, and you have a free radical again, which takes up the water, and you get an OH. Two OHs on the same carbon and automatically turns in, unless it's like formaldehyde or something like that, automatically will turn into a carbonyl. Then you got an H here, and it took the water off of here, H2O, and made a carbonyl, right? And again, the NO comes in, takes off the hydrogen, you're left with a free radical. The free radical grabs up a OH off of the water, just like it did the first couple times. And now that's what you end up with, is toluic acid. Keep in mind, this all is just I'm talking out my ass. I have no clue what the mechanism is. I did take that and I melted it. It started melting at 97. I took it off because I didn't want to really melt it all. I don't know about sublimation with it, because I know phthalic acid sublimates. So I took it off, but a lot of it was melting. I mean, it was just unreal. The actual procedure is for ortho-xylene, and I used mixed xylenes. So that may play a part in my low yield. Mixed xylenes in general are 40 to 65% meta and 20% para, 20% ortho. Ortho is what the thing was going for. It might be easier to do ortho. I don't know. You know what I mean? I have no clue. What I used was probably, and this is just a guess, but it was a little bit better than this because I distilled it out. But there was a lot of ethyl benzene in it with it. So I took the lower ones, the lower boiling points out first, which are these two. So I probably did get more ortho and less para and meta. So mine is probably this, 50% meta, 10% para, 30% ortho. So I don't know, maybe you can't do it with para and meta. You know what I mean? And so I only used 30% ortho, so only 30% of it reacted. I don't know. Also should have taken, and this is a bad suggestion. This would I might do next time. I do not suggest you do it unless you have some kind of blast shield or something like that. But in video, whatever, when I first got it out, you know, right after the refluxing, you know, after I mixed the three things together and refluxed it for, you know, 7.5 hours and 55 hours. When I filtered that out, I actually had more than 70 grams, because later on you'll see in the next video I weigh it up and I say I have 70 grams there. But in the previous video, right after I take it out of there, I thought it was supposed to be there, so I didn't have an audio thing. I put it like a posted where text come up and it says I have 70 grams. That's actually wrong. There was more than 70 grams there. I never weighed it though. But either then or later on when I verbally say, hey, this is 70 grams, and that's when it really was 70 grams after I purified. It must have weighed more though before then, because I put it through some purification stuff, you know what I mean? Either one. I should have taken that and stopped, because I'm just going to use it for soda lime decarboxylation. So whatever is impure in there, you know, I do the soda lime decarboxylation. I get the toluene, methylbenzene, and I'll have some contaminants come over with it probably, you know, and then I'll distill that and get my toluene more pure, you know what I mean? Because I lost a lot of stuff doing this, you know, trying to purify it better. The bad thing, and why this is, I don't suggest anyone do it, is because you don't know what's in those contaminants. You know what I mean? It could be explosive stuff under a soda lime decarboxylation. I mean, soda lime decarboxylation, you putting torches directly onto the container. Most people don't even use glass because they don't want to break it. You know what I mean? So this is extreme heat, and you don't know what the reaction could be. It could be, I mean, if you got a blast shield, it's great. You know, do it in the blast shield. But I don't know what would happen if you did that. So I purified mine, plus for the video, you know what I mean? Oh, and another thing was when I filtered, okay? Remember when I was filtering stuff and I says, I can't filter this, I can't filter it, and I ended up decanting it? That was a waste of time filtering it. I should have just put it in a long, and I lost a lot of product, you know, because you filter something. I must have filtered it like 100 times. That's 100 times, even if it was a milliliter of stuff I lost. I lost 100 times that, 100 milliliters, you know what I mean? I kept putting more and more alcohol in as it evaporated, and, you know, I lost the stuff, you know what I mean? So that was a big loss, a big loss. I mean, I literally filtered them probably at least 50 times, at least. So that's a big loss, you know what I'm saying? Shouldn't have done that. If I was going to do it, I should have just put it in a graduated funnel, like I said, so it's nice and tall, nice and skinny, and let it settle. And oh, and another thing I want to tell you is something like that you can put in a bottle, say, you know what I mean? I should have put it in a bottle and got a like a pillowcase, you know what I mean? But you got to think, man. You know what you're swinging around could break, or, you know what I mean? Let me get an example here. This bread bag is the pillowcase. The bread inside is the bottle. You know what I mean? You'd have to have the bottle sticking straight up and down, even if you have to, you know, roll the pillowcase and tape it, you know what I mean, so that it stays straight, so the bottle stays standing up. Then you just twirl it. That's it. You know, twirl it 5-10 minutes, take a break. Twirl it another 5-10 minutes, take another break. Twirl it another, you know what I mean? And that's basically like a centrifuge that you're just doing yourself. That would force the contaminants, you know how I was letting them settle. This would, if you do that, it forces it to go to the bottom of the container, right? Just like if you have an open container and you do that, none of this liquid will fall out because it's all being forced to the bottom of the container. That would compress it and get the solids out a lot better. It's just I have a bad back, so I didn't do it because I'd throw my back out. But that would have definitely helped. I lost a lot of product, and I spilled some during that. Just filtering all that stuff out. And I didn't do a good job on anything when it came to that area there. But if I would have put it in a bottle in the first place, a nice thin one that's tall, twirled it around like I said, would have been perfect. Well, this is the last thing. Probably might be the most important thing. Now here's our ratios, remember? Remember, this is, according to the instructions, should have been ortho. Orthos, I mean. But here's the thing is, you got 1x here, you want twice as much nitric acid and twice as much water as the nitric acid. So here's some examples. If I had 100 milliliters of this, I'd have 200, 400, 150 of this, I'd have 300, 600. But you can see these add up to a lot. This takes up a lot of space, man. That's 700 milliliters total, right? That means you need a 2,000 milliliter bottle for that. The most you could do is this. And you couldn't even do that really because you'd be over 1,000 milliliters. You'd be 50 milliliters over what you should be. I mean, you can get away with it if you're careful, but I wouldn't want to do that. So you can only really do 100, 150 milliliters with this big size flask. The second thing I don't like about it is because this is so giant. You know how much it takes a lot of heat to heat this 2,000, 1,000 milliliters of liquid up, it takes a lot of heat. Okay, that's another thing I don't like. Another thing I don't like is, look, this is where it'd be filled up at, say on my thing. This is the amount of xylene I put in. It's surrounded by nitric acid. Yeah, it's dilute. It's dilute, don't get me wrong. It's 30%, so I mean, 2/3 of it is water. But look at that. It's surrounded by, you're just asking for over-oxidation if you ask me. Okay, that's just, I don't know. I could be wrong, though. But it seems like it's surrounded so much. Look at this. If I did this again, look at this. This is a 500 milliliter flask, okay? I got my step funnel here and my, the rest of you saw the video where I'm refluxing it, right? This, I mean, down here, I could put the same 100 or 150 milliliters in, right? And then, well, I'll do this example over here for the 100. I must have not done the 151. So if I did that, I could put 100 milliliters of 30% nitric acid into the pot. That's only 200 milliliters total, right? That means I can use a 400 milliliter flask. Of course, they don't usually come that way. They're 500, so you can use a little 500 milliliter. That's easy to heat, right? Because you're heating this all the way up to like 140 degrees Celsius. That's a lot of heat. You have barely anything to heat, but you still have a lot. It's a 1-to-1 ratio in there of the xylene to the dilute nitric acid. You know what I mean? So you still have it's dilute. This way you have a lot. It has, instead of attacking a xylene thing a second time like over here there's so much xylene it's going to attack a new one each time. You have a better probability of it attacking a new xylene instead of over here where it has no choice almost but to try to attack the same one. Then in this thingy here, right, because you can see 4, 5, 6, you got 600 milliliters, say, you put 100 in your flask, you only need a 500 milliliter equalizing funnel, and you could put the rest in there and drip it in as it goes or whatever. I don't know. Didn't seem like the level went down here that much. So I don't know if this would actually work or not, now that I'm thinking about it. Because it wasn't like, even though there was a lot of gases escaped, this liquid level stayed the same. Maybe if there was, maybe, I don't know, maybe leave the 500 milliliters out and just go with 100 milliliters and put 400 milliliters of the 30% in there and do it for 3 hours and see how it works. You know what I mean? Or do it for 2 hours. See how it works. I think that would be better. And then just do multiple reactions, 2-hour reactions. You might not be able to do this funnel thing. But anyway, or maybe use the same big 2-liter flask, but only put the same 100 milliliters of xylene and 200 milliliters of nitric acid in here, and the rest put in a set funnel. That way you could only have to heat up 300 milliliters instead of 1,000. You know what I mean? That's a lot better. Anyways, these are just thoughts. I don't know. I'm just thinking. Anyways, always remember, science is great.